Okay, we're just waiting for 9:05. Actually, you know what? This is something that we did do at the end of yesterday's lecture, so I'm just going to repeat it now. So I can repeat it now before today's lecture begins. So just a reminder of the Moody's method. And again, I did this one right at the end of yesterday's lecture. And I did it quick just to show you that it's not as tedious as it looks like, when I'm showing you the steps one by one, that you can do it all on one graph or one table. And it goes relatively fast once you get the hang of things. So this would be our table 2 that we received from yesterday. So remember, we did one like iteration. Well, we did the Northwest, which set up the initial basic feasible region. And then we did an iteration from there. And we got our table. And if we move back, we had our Northwest. And then we went and did a table. And we changed it with the bringing x22 in as a basic variable. Basic variable, again, is just a variable which is non-negative. Well, it's a variable which is non-zero. It's a positive value. Okay, and it's part of your corner points. So the corner points where there are actual numbers and not just zeros. Everywhere else is just zeros. And then when we brought in x22, remember we chose the smallest negative value here. And why do we choose the smallest negative value? Because remember, we'd want to keep our constraints being met. So we brought in, this 10 kind of a situation. So we added 10 here, subtracted 10 over there, and, added 10 here and subtracted 10 over there to get us to that next table. And this one looks dirty because this is the one that we did yesterday to do the new steps. So let's just go. We have that. That is a 20. Yes, I just can't read my own handwriting. Okay, so we have this table. We have the 50, the 20, the 10, the 5, the 20, and the 20. If you're given just any table and then told to do the next iteration, you can already start checking. So you can make sure that, remember, you need however many rows you have and however many columns you have, minus one of them have to actually have values in their table. So in this case, remember, we have 5 columns and 2 rows, so that's 7, minus 1 is 6. So we need 1, 2, 3, 4, 5, 6. So this table is set up and ready to go for us. And you notice 105 and 105, so the supply and demand are equal to each other. So let's just go from here. Like if you're given a table, can we do the working out? And we can. So I'm going to use the Modi steps. So if we use the Modi steps, the first thing we have to do is find the R's and K's. So the first thing we do is we say, okay, well, that's equal to 0. And then we go and find, our K's and R's that are left over. What we're using for this is we're having the cost is equal to your Ri plus your Kj. And remember that J is just referring to your column and the I is just referring to your rows. So we can go ahead and work things out. So for your K, you just make it the subject of the formula. So you'll have Kj is equal to, and you're going to have Cij minus Ri. Right, so we're just going to go ahead and do all our working out. So if we go ahead and do all our working out, what's nice is you can read it straight from here. So you can have 24 minus the 0. 24 minus 0 is going to give us 24. So we have K1 is equal to 24. Then we're going to go on to the next one. And we have, can we do this one over here? And the answer is no, we can't, because remember, when we're working this out, we're only using the ones that have values inside of them. So the empty ones we don't look at for this. So we move on to, where there is an actual value. So we can move on to this one over here. So we have 5 minus 0 is equal to 5, and that gives us K3 is equal to 5. And again, we don't do the empty cells, so we move on. So in regards to this, when we're moving on, you'd think possibly about wanting to, go straight to this one over here and utilizing that. But you'll notice we currently have 2 unknowns. So that's an unknown and that's an unknown. So obviously you can't do that one yet. So you would try and get, utilize a column that already gives you your K value so you can find the R value and work from there. So in this case, we have a K value over there. So you would either utilize that one or that one. This one has an empty cell there, so you will not be able to utilize it as a way to find your R. So you would have to obviously choose wherever there is a value and there is a K value there to get your other R. So just be aware of that and take note of that. Okay, so we're going to utilize the one where there is a K value and it is in that row. So it's this block over here. So we have that 20 and we have that 5. So remember, to make R the subject of the formula, you're going to have Ri is equal to Cij minus the Kj. So it's 20 minus 5. So 20 minus 5 gives us R2, which is equal to 15. Now that we have the R, we can go back and find, for the other K values. And again, we're just using the same process as before. So we'll have 24 minus 15. And that is going to give us 9. K2 is equal to 9. And then we go to the next one, 2 minus 15. And that's going to give us 13, or minus 13 actually. Minus 13. And then we have 18 minus 15. And we have, 3. So we've done step 1. So remember, step 1 is all about, just finding your R's and your K's. And you repeat until you find all of them. Now what I'm going to do is I'm just going to make this a little bit neater so we can go to step 2. Right. And step 2 is you want to find your differences. So remember we spoke about this yesterday, and the differences are actually going to tell us that if we bring in one of those, non-basic variables into as a basic variable, in other words, we're going to increase them from that 0 that they are, because remember all these empty ones are technically 0. If we bring them in other words, we make them a positive value, that difference is going to describe how much it's going to, the effect on the objective function. So your difference describes the effect on your objective function, whether it's going to increase or decrease per unit that you increase it. So when we work out these DIJs, they're actually saying, listen, if we increase any of these, wherever they sit, so if it's this one over here, if we increase it by 1, this is the impact it's going to have on the objective function. So your Dij is equal to your cost minus your row value plus your column value. Now, behind the scenes, linear algebra is happening there to make that happen. We're not going to discuss that. So you just trust us that is what it's going to do. Right. So let's go ahead and find all our Dij values, and which are the differences. So because it's, your cost minus your row and your column, and it's for all the empty cells, we go to the
Sorry, ma'am.
Yes?
I just want to ask, why do you skip some of the blocks like W2, W4, W5, and then W1 for F2?
Okay, so when we work out the rows and the columns, we can only use the ones that have values inside of them. So we can only use those to work out our R's and our K's. And that is to do kind of with the fact that those are the ones that are utilized in our solution. They're the non-zero values. So they're going to have an impact on it. And the math is a little bit behind the scenes, like linear algebra and stuff, but those are the active constraints in a way. So, because obviously they're making up the corner points. And those are the ones that are going to affect this R and the K values in regards to that, because they're the active ones. That make a little bit more sense.
Not really, but I'll try and figure it out.
Okay, we can discuss this maybe afterwards again, because it is math that's not necessarily needed for this module. So most people just go with the trust that it works, and If you want to know the math, I'll discuss with you after this.
Okay, thank you.
Okay, so just a reminder that when we're doing the R's and K's, we only utilize the blocks with non-empty cells when we're working out the R's and the K's. We then work out with just the empty cells our differences. So we are still going to do these cells now, but we're going to use these cells to work out our differences because these are the ones that are not actually in our solution exactly because they are set as 0. So the ones that aren't in our solution right now, we're going to investigate if we move them into the solution. In other words, we are going to, move our corner point from, say, chilling over here to maybe chilling over here. How is that going to affect our objective function solution? So it's going to tell us, whether the objective function solution is going to increase or decrease. So we look at the Dij and we have the 24 minus the 0 minus the 9. So 24 minus 0 minus 9. And that is going to give us, I'm terrible at math, it's going to give us 15, right? So we have, that is sitting as 15. We're going to move on to the next empty cell. We have 20 minus 0 minus 13. And in that case, it's going to give us 33. Then we're going to have 20 minus 0 minus 3. And that's going to give us 17. Then we do the last empty cell of 30 minus 15 minus 24. And that is going to give us minus 9. So once again, what this value is actually telling us, it's telling us if we had to increase, and let's just choose this color here. So this is actually x12, right? If we had to increase x12 from 0 to x12 is equal to 1, it's going to impact the objective function by increasing it. So for every unit that we increase x12, it's going to increase our objective function by 15. So obviously, if we're doing a minimization problem, we do not want to, increase our objective function, which is why we're going to look at only the differences that are negative. Okay, so in regards to that, obviously this one is not, that one's not, and that one's not. The only one that's negative in this situation is this minus 9. So you're like, oh, that's going to, for every unit, that you have this, it's going to decrease it by 9. That's a good idea. Let's bring it into our basic solution. So again, I'm using the word basic and non-basic. Basic just means that the variables involved are positive values that are not 0. So it will be a situation of, if you had to look at like this corner point here, where you have y is equal to 0. Let's just do it. Yeah, okay. So this is obviously not fully mathematically correct, but I think it's the easiest way to just show it to you and say x is equal to 3. So let's have that as 3 and 0. This 3 is classified, as a basic variable, and that would be kind of like a non-basic variable. Not 100% true, but we're going to go with, that's just your idea kind of a situation. And when you look at that, you will see there's like 2 constraints that are making up that point. So what we're doing now is we're moving it. We're saying, well, we no longer actually want that constraint as part of it. We want to look at that constraint. And that's what we're doing when we're doing all this working out. So we just actually still utilizing the constraints, but flipping them and seeing, activating only certain ones of them. Okay, so this is what we're basically doing when we're doing this process. So what we're going to do now is we're going to be like, okay, we want to bring x21 into our solution. So we want to make it from 0 to something of positive value. How can we go about doing that? And now we need to look at the fact that the constraints need to be met. So if the constraints need to be met, that means that, this one has to work out, and this one still has to work out. But right now, we have in the situation where the constraint is being met exactly, because you have that 10, you have the 5, you have the 20 and the 20, that's giving you 55, and that 30 is giving you that 30. So if you have to increase x to 1, you're going to have to change, this 30 here and one of these variables over here to allow for, the constraints still to work out. So we're like, well, we want to increase x to 1. So we have a plus sign over there. So you want to increase it. Now we're just going to work out, like, if we increase that one, which of the ones are we going to need to decrease to, keep things balanced? We will work with the column first because it's a little bit easier because there's only 2 of them. We're like, well, you need to decrease this one here. Okay, so if we need to decrease that one over there, we're like, and at that moment in time, you're like, well, then I'm done. No, you're not done, because we still need to do the row. So the row is, we can either decrease this one, or this one, or this one, or this one, right? But now we need to also consider, and this is where, that loop comes in, is if we decrease this one, this 30, that means we've messed up this constraint. So we need to fix that as well. So we need to obviously add to one of the other active areas. So one of the other active areas are one of those variables which are already basic. So it's the ones that are, have a value, they're not empty. So we'd actually have to add to this one here. Sometimes you'll see 2 or more, but in this case, there's only one that you can add to. And that's going to tell you that out of all the 4 at the bottom that we can choose for the x21 fixing that one, the only one we could really use is that, because we need to have it so that everything cancels out. That's where the rectangle and the square situation comes in. It can get more complicated. You can have a structure that goes, that changes, then you have like down here and you loop kind of situation. But the idea is, wherever you make changes, you make sure that all your constraints are going to be met. So you have this loop occurring. Okay, so we have this loop occurring. We know the loop now. Now we need to figure out how much can we actually increase x to 1 by, so that we still have all these constraints being met. And to do that, we have to look at the negatives, because we're taking away from them, because that's what we have available to us. So what we have available to us to shove into x to 1 is the 5 and the 30. But obviously, to maintain our constraints, so to maintain, I'm running out of colors here because it's looking kind of scary, to maintain this over here, and to maintain this one over here, we need to choose the one that's the smallest, or the largest negative, well, the smallest, basically. Let's just go with the smallest because it makes more sense. So you just look at the 5 and you look at the 30 of the negatives and go, which one is smallest? And you utilize that one so you maintain keeping your constraints. Because here you choose 5, then you'll be subtracting by 5 here. So then it's still going to work out, it's still going to add up to 55. But if we had to choose 30, obviously things are going to break for that row. So just be very careful about that and acknowledge the fact that when you do this, so you have the loop's there to make sure that you're going to maintain all your constraints. And then you're going to select the smallest of those negatives, because those are the ones that you can actually get the values from, to meet your supply and your demand constraints. And then you choose the smallest one to make sure you still have both the constraints being met. When we're talking about both constraints, I mean about the column constraint and the row constraint related to the x21. So we have that 5 happening. So now we're almost at the end of this one. We're going to increase this one by 5. Then we're going to decrease that one by 5. We're going to increase this one by 5 and decrease that one by 5. So we're going to end up with, that is going to be 25. Okay, that's obviously going to be 5. We don't have to do any extra work now. That is going to be 25. And that is going to be 0. So notice what's happened here is the moment we brought in x21, we end up with a variable that used to be basic becomes non-basic. And again, non-basic just means it's 0 in your eyes. So we have that situation of what's actually happening is that particular one is chilling there on the 0 situation. So there's going to be a constraint that's no longer active, which makes sense because when you're going through your different cornerings and stuff, you will have a situation where, and I'm going back to the basic one, you were here and now you're here, one of those constraints is no longer active in your corner point. That's what we mean by this whole, basic and non-basic kind of situation. Now, that obviously looks really, really scary. So let's rewrite that table neatly. And we have, 25, 25, 5, 10. That one becomes 0. And then, I wrote it neatly over there. My bad. So there we go. We have it written neatly. So this would be the next table iteration that you'll use. Any questions at this moment in time, though? Okay, there's no questions at this moment in time. I'm going to show you the parts where it's not the funnest because now you have to go through the process all over again, and you have to keep on going through the process until those D values are all positive. So we go through the process again. So once again, we are going to use our cost, our CRJs, is equal to Ri plus Rkj, and it's for the ones that are active, it's the basic variables, and related to the stuff that is currently active. So what is actually making an impact? And then we find our R and our K values. So all the ones that are non-empty. So we're going to do this for all of these to work out our R's and our K's. Again, it's connected to the things that are already active in your objective function. Okay, so objective function, when you go ahead and you do everything, you will end up with, remember, it's 24 times 25 plus, 25 times 5 plus 5 times 30 plus 10 times 24 plus 20 times 2 plus 20 times 18, and that will give you your cost. So now when we're working out our row values and our column values, our row values and our column values are connected to, what's happening in the objective function and the current solution situation. So we go through the process, and again, in this course, we always just choose R1 equal to 0. There is a best practice. We won't discuss it. We will just go with this method. And we go through their approach. So we have 24 minus 0. That's going to give us Rk1 is equal to 24. We move on, and we have, I'm going to look at this one over here, 5 minus 0, and that's going to give us Rk3 is equal to 5. So you've done that one and that one. And we now need to, because it's in a new row, so we need row 2. So we know we need row 2, so we got, where can we actually work that out? And remember, you choose whichever one where you have it, only one unknown. So in this case, it will be the first column because you have your K and you have your Cij, so you can work out your R2. So that would be 13 minus 24. And that's going to give us 6. So our R2 is equal to 6. And then we move on the process. So we'll have, we can go work out the rest of the Ks. So we can do this one here, which is 24 minus 6. And that is going to be 18. Okay, so we did that, minus that, gave us the 18. Then we have the 2 minus the 6. The 2 minus 6 gives us the fourth K, which is minus 4. And I know that doesn't look like a minus 4. There we go. And then we do the last one, which is 18 minus 6. And 18 minus 6 gives us 12. So the fifth K is 12. And once we have that, so once we have all the R's and K's, which are dependent on the values which are, active, in our solution. So they are adding value to our objective function. They increase in our objective function basically because they're not zero. And we use those to work out the R's and K's. We can then use those R's and K's to work out how much impact the ones that aren't active in our objective function solution are going to have if we put them into the objective function solution. So again, our difference, when we work out our differences, it's your Dij, it's equal to your Cij minus the Ri plus the Kj. And I just want to say that again, because it is connected to the question that was brought up earlier. So remember, when we work out our R's and our K's, we work out our R's and our K's based on the ones that are active in our objective function. They are increase in our objective function. They are non-zero values. They're giving it a value. They're giving it, a cost. We use those to work out the R's and the K's, and then we use the R's and the K's to work out, because it's having an impact on the objective function value. We then use those R's and the K's and that, the cost to work out if we had to bring in the ones that are empty, in other words, the ones that are equal to zero right now, make them positive values, what impact it will have on the cost function. So that's also one of the reasons why when we solve our R's and our K's, it's the ones that are non-empty because of the impact it already has. And then we utilize, the R's and the K's that we worked out for the ones that are non-empty for our differences, which are currently sitting at zero. So there is, that there is an actual impact. It's not, just happening by chance. So let's go ahead and work out all our differences. So again, it's your 24 minus your 0 minus your 18. And that is going to give us 6 again. Oh, okay. Then we go 20 minus 0 minus 4. And that's going to give us 24. And then we're going to have 20 minus 0 minus 12. And that's going to give us 18. Once again, if you're wondering where I'm getting these values from, I'm going 20, I'm going 0, and then I'm going the 12. No, it doesn't look like 12. Then we move on to do the rest of them, which is one more left over. So 20 minus 6 minus 5. So 20 minus 6 minus 5, and that is going to give us 9. Now, we at step 3 in our MODI, which is basically look at our DIJs, and we have the 3 steps. So if our DIJs are all greater than 0, we're done, we're at optimal. If our DIJs are not all greater than 0, and there's one that is less than 0, we choose that one, which just basically means it's not optimal yet, and we need to go through the iterations again. If it's equal to 0, it just means that there is an alternative solution, which is going to give you the exact same cost function. Because remember what this Dij is saying, it's saying that if you increase your unit over here, your x12, by 1, it will increase the objective function by 6. And if you increase your x14 to 1, it will increase your objective function by 24. So in this situation, we're at the point where it's like, hey, we are solid, we're at the optimal. So we can actually stop at this moment in time and say, hey, we're at the optimal. The optimal is, and let's write this down, the optimal is where x11 is equal to 25, x13 is equal to 25, x21 is equal to 5, x22 is equal to 10, x24 is equal to 20, x25 is equal to 20 with a cost, and the cost is, just taking that and solving it, of 1515. So we have an optimal solution. Optimal solution is where all these points are these values, all the others are equal to 0. So you can write out the others equal to 0, but we only really care about the ones that are not 0. with a cost value of 1515. Any questions at this moment in time? Okay, if there are no questions at this moment in time, let's go do another example, which is kind of the example I spoke about yesterday, where I said sometimes we won't have the right number of values, of non-empty values, and what can we do about that? So the cost, I took the 25 times by the 24, plus the 25 times by the 5, 5 times by the 30, 10 times by the 24, 20 times by the 2, and 20 times by the 18. So this is just the equation where it's coming from. Remember your original, if we go all the way back to the original problem, and let's just see if I can do this. No, don't do it like that. Zoom out. Okay, all the way back to the original problem, the epic long way. Sorry, didn't want to do the cool zoom thing it usually does. You would have, this, your objective function equation was everything in the middle here, just added together. And these are the coefficients of these values. So I will discuss this in the next example as well, where you could read the entire structure of your problem from this table of your constraints, and then the middle part was the objective function equation, which is the summation I equals 1, summation j equals 1, xij times cij, where thecij's are all these values over here. I was going to show this, but there we go. Okay, so let's go to the next example where we can also discuss how we set it up and where does everything come from one more time. Right. So here's another example. And again, you'll always get your examples with a couple of factories, a couple of warehouses and everything, and you'll be able to set it up in a table. And usually they'll give you a table where the costs are, associated, in this table below, where they're like, hey, going from factory A to warehouse 1, it's going to cost 10 units per unit, or 10 rand, dollars, whatever you want to call it, per unit of whatever item you're shipping. So they'll give you a table that is the shipping cost, and the shipping cost, it's like it costs 10, and let's just call it 10 rand for shipping from factory A to warehouse 1 unit. So what's happening is your decision variables are 1 unit from factory A to warehouse 1, and that's where we get that whole, when I talk about this X11, it's, factory 1, which in this case is factory A, and 2-1, and that's warehouse 1. So the rows and the columns match up with your decision variables. And this value here currently is how much it would cost to transport 1 unit of that from that factory A to the warehouse 1. And that's why when we do this whole process, when we're doing the objective function, it's the summation of all the xij's with multiplied by the cij's. It's because it's sitting here, in the table. And we have x11, x12, x13, x14, and then x21, x22, x23, and x24. That is technically your objective function equation. So that whole centerpiece is technically your objective function equation if you add in your coefficients. And when we redraw our graph, or not our graph, we redraw our table, we redraw it so we actually just shove these coefficients to the corner because we're interested in actually finding what these, the decision variable values are. Those are the things that we need to find out. We already know what the costs are. We want to find those decision variables. So again, let me just clean this up. So usually you'll get a question, with this kind of like table, and they'll also give you, or they'll give you like a list and tell you all the costs, and you'll have to build up this table. This table is missing, however, the supply and the
Sorry,
demand.
ma'am.
So, yes?
I just want to ask, where did you get all those coefficient values from, or did you just make them up?
I made them up, or technically I got them from the example, but you guys will always be given them. So
Okay.
you will always be told what the costs are.
Okay.
Okay, so
Thank you.
when you get this problem, you will either get the costs in the table like this, so you'll get it with this table, or you'll get a list of them. So it'll be like to ship from factory A to warehouse 1, it costs 10 Rand. And they'll give you like a list for every single one of them. So you'll have 1, 2, 3, 4, 5, 6, 7, 8, 8 like little, statements chilling on your list. So there is different ways to ask this question. They can either just give it like that, or they can give it to you as a table already. So it's just bear that in mind. And if they give it to you like this list, you will have to create this table. So you'll have to basically convert. And usually what you'll do is you'll always have from, sitting here as a column and all your factories, and then you'll have all your warehouses chilling here as different, down the road kind of situation. So you'll end up with your constraints and everything. And that brings us to this table is actually not finished. So remember when we did the other one, we already had the supply and the demand in the table. So we actually have to edit things and add some more information to this. So if we have to go ahead and look at that, the factory have the following capacities. So factory A has 110 and 90. So it can only, in regards to this, it can only supply 110 units and factory B can only supply 90 units. So you actually have, the 110 chilling over there and a new, column called supply. And then you'll have the 90 chilling over there because it can only supply 90 of them. And then the warehouses have the following demands. You then go to the warehouses and you add that part of the constraints into your table. So you'll have the 90, the 20, the 70, and the 20. So just be very careful about that. The building up of your problem, your costs originally will, go in the centers, you'll move it next. And then you'll have your supplies, sitting on the one side. And it's the same as like if when we built up linear programming problems, if it's connected to, whatever is in the row, then it goes to the end of the row. If it's connected to a column, then it goes there, the lowest down here are the columns. And just again, a reminder about this is technically sitting there as less than or equal to kind of situation when you're going through
How
the
did you
process.
get 110 and 90?
The factories have the following capacities. A is 110 and B is 90. So it's that piece of information over there. Okay. So we read the information, we put it into the table. We're not finished yet because we haven't even actually started. We've just built up the table. Let's neaten the table up. So obviously my handwriting sucks. So we neaten up the table. And you'll notice what I've done already is I've taken those costs and just push them to the corner because that's, again, we want to focus on our decision variables. So we neaten up the table. We actually push the costs to the corner so that when we do the whole working out, we can read the decision variables because those are the things that are important. Now, at this moment in time, the first thing we're going to have to do is actually make sure that the supply meets the demand. If the supply does not meet the demand, you're not finished making up your table. So in this case, supply is 110 plus 90, that gives us 200. And the demand is that 90 plus the 20 plus the 70 plus the 20, and that gives us 200. So we're okay on that front, which means we don't need any additional rows or columns. We'll discuss that next week. So if the supply does not meet the demand, you have to tweak your table. If it does, we're good for what we have now, where we've taken our information, we put our costs, sitting for FA to W1. We were told that it's 10, so it sits in that nice little table. Alternatively, we told this and we actually have to draw the graph. We added the information we have about capacities to our table, in the areas that were necessary. So we had the 110, the 90, the 1990, the 90, the 20, the 70, and the 20. And we then just shove our costs to the corner. And we have the basic structure of our table. So again, if the supply does not equal the demand, you have to tweak your table. So always check that before you move on. Here it does, so we can move on to the next step. And the next step is this table currently sits with, all these values as 0, which is obviously not correct. So let me just, before I move on to the northwest corner method, go through one more time how you can read stuff off this table. So remember, all the center ones are actually the decision variables, what those variables are. And when I'm doing this, it's the row number and then the column number. X22, X23, and X24. And when you read this off, let's actually just do that before we do anything else. We have our objective function is minimize the cost. We know it's minimized, that's the point. But our cost equation is that 10 plus 10 times 10 x11 plus 15 times x12 plus 21 times x13 plus 17 times x14 plus 5 times x21 plus 12 times x22. And I know you're probably slightly annoyed about me doing this, but this is just to cement the idea that you can read the stuff off the table. And 4 times x24. So you have everything in the center is going to give you your objective function solution. And that's basically just the sum of I equals 1 to n, and the sum of j is 1 to m. And in this case, j is 4 and I is 2 of your Cij and your Xij. You don't have to overly care about that. That's just to connect how I explained it yesterday. Now, you actually have more information because this table tells you your entire setup. So it's also telling you, and let's just rub this out so we don't get overly confused about everything. It's also telling you what all the constraints are and what all, so all the constraints, you have your demand constraints sitting here. Let's do it like that, so that you don't get confused by using the cost values. So it has all the demand constraints chilling like this. And what it's actually saying, it's saying subject to, and you have x11 plus x21 must be less than or equal to 90. Okay, so it has the constraints sitting there. And when you're doing this whole process, when you're solving this, you're actually solving it at the extreme points. And whereas at the extreme points, that's pretty much where they're equal to each other, which is why when you do all the working out, and when we first do the northwest corner method, we make sure that, when we do the stuff, it actually has a situation where it equals the demand equation, because it has to sit at the extreme point. So it has to be a case where it is equal to it, because it has to sit on the boundary for that. So we have all these are the different constraints for the demand, and we're going to have the constraints for the supply, and that is this situation here where we have x11 plus x12 plus x13 plus x14 is less than or equal to 110. So we have, our constraints relating to that as well. Right, so let's now find the initial basic feasible solution. The initial basic feasible solution is just any corner point in our feasible region, and we use the northwest corner method for it. So in other words, we want to find a solution of the x11, x12, x13, x14, just so that we're inside our feasible region, because the Modi problem or the Modi method utilizes the idea of moving around. So if that's our feasible region, the northwest corner method is going to find a way to get any of these, not necessarily the optimal. It's just going to find a corner point, which is technically an extreme point. In this situation, it's called an extreme point. And then the Modi method will, investigate or move around to the different corner points, and we can test to see if it's optimal or not based on those differences. So let's find the initial basic feasible solution. It's just the first solution. It's not going to be necessarily the optimal solution. That's the northwest corner method. Okay, so I'm just cleaning it there, and let's do the northwest corner method. So the northwest corner method is where you take the northwest corner and then you investigate the supply and the demand, and you choose the one that's lowest and you put it in to that northwest corner. Then you subtract it from both sides. And why you're subtracting it from both sides is because, remember, these are constraints. So remember, it was constraint x11 plus x21 must, have that 90 kind of situation. And then you have the x11 plus the x21 plus the x12 plus 13 plus x14 is equal to 110. And that's going to, if you already now have used 90 over there, the easiest way for you to work out the rest of them is to subtract it already, so that you don't have to worry about it, because then you have x12, x13 plus x14 is equal to the 110 minus the 90, which is why we subtract the 90 there. So when we investigate and we explore it, we've already accounted for the fact that the 90 has been taken out by this slot. So we have, that 90, 110 minus 90 gives us 20. So we're going to go through that process. If that gives us 20, and then we say, well, we've already solved for this constraint because the demand now is equal to 0. So we actually can't put anything over here because this constraint, this column has already been met. So then we move on to the next northwest corner, which happens to be here. And we follow the same approach. So we investigate, in this situation, we investigate the 20 and the 20. And both of them, 20 and 20 is the same thing. So we shove 20 there and subtract it there and subtract it there. 20 is equal to 0. Now, this is a special case situation because, again, you'll only really scratch out the row, the column of where it's 0. And in this case, it's 0 in both of them. So what's cool here is what's happened is this constraint has been met, the column constraint has been met, but the row constraint has also been met in this situation. So we can't put in anything in, x13 and x14 because it'll break the constraint. And we also can't put in anything for, x22. So we cross out both of them. And then we look for the next northwest corner. So we look for the next northwest corner. Yes.
I didn't understand why you have to remove that other column there, the one that is going horizontally, the one with 21 and 17, because the other columns I do understand that it's 0, so that's why we remove them, but that one there is 21 and 17. So why are you
Okay, you're looking at the wrong value. So over there, you're looking at the 21 and 17. It only impacts your objective function. That's why it's shoved in the corner. So when you're working out the constraint is actually, you have this is actually x11, this is x12, this is x13, and this is x14. And the constraint is you adding these all together, they must be less than equal to whatever's sitting in the supply. But we have x11 is equal to 90, and x12 is equal to 20. So we've already met our constraint. We can't go any further there. So this x13 and the x14 can't have values if we want to maintain our constraint. And it is something that it can be a bit frustrating because you do have your cost values sitting there in the table. So just be very, very careful when you read your tables. So I'm just going to go back to this one for a second, that your constraints are, like that one. And you have a constraint here, which is chilling here and is not including the cost coefficients. So it's just the adding of that kind of situation. So that is a constraint. That is also a constraint. Does that clear it up a bit?
Yes, so in other words, you're saying all of the constraints that we're gonna get is gonna should meet up to 110, and then should also meet up to 90 for the first row in column, and then for the second row it should meet up to 20, and then for the third row it should meet up to 70. And if I understand what you're saying very well.
Yes, except just be careful that when you go down, it's called a column. So the row is the side and the columns are the down. But yes, basically what you're saying is correct. So when you have all these constraints, remember it's x11 plus x21, and that 90 kind of situation, the 20, the 17, the 20, but you also have the rows are also happening.
Oh, okay, thank you.
Okay. So this one is the one that is slightly trickier because you have a situation where both the supply and the demand are back down to 0 now. So you have, that 20 and the 20 cancels, the 19 and the 20 give you that 110. So you have to, scratch out both of them because both of those constraints have been met. Usually it's just one, but in this case, it happens to be 2. This one has a degenerate solution. Degenerate, don't stress too much about that. It just means that one of your basic variables is equal to 0. And we will discuss this in a second. So in this situation, you scratched out both, you still continue the northwest corner method, you just go to the next northwest corner. So in this case, you'll come down to this one over here. So you're now in that block. And in that block, you now have that situation of you're looking at the 70 and you're looking at the 90. And you choose the smallest one, so that's 70. Then you say, okay, well, that's minus 70 is equal to 0. And minus 70 is equal to 20. So you have 20 left to play around with in that, for that constraint. By that constraint, we mean this row constraint. And then you move on to the next northwest corner, which is the final one, which is this one over here. And you'll notice, particularly the reason why this works out so great the way that it does is because our supply and our demand are equal to each other. If it wasn't the case, it wouldn't work out like this. So you have, the 20 sits there, and that's going to give you 0, and that's going to give you 0. And again, then now all your constraints are being met. So now we have a table. We have the first initial table. And let's just write this slightly neater. So we have that 90, we have that 20, we have that 70, and we have that 20. Now we have to, remember earlier I said you have to check the supply and the demand is equal to each other. Now, once you have values in here, you need to check that you have a correct number of them. So remember we said that the number of non-empty cells, in other words, the number of basic variables, in other words, the number of variables, the decision variables which are positive values that are not 0, have to be equal to your number of your columns, and that's you have 1, 2, 3, 4 columns, and the number of your rows. So you have 1, 2 rows. So you have 4 columns and 2 rows. That's 6 minus 1. So you actually should have 5 non-empty cells, or 5 basic variables technically. So you should have a solution with 5 decision variable values, and then the rest are zeros. But when this happens like this, where you have 4 instead of 5, you can't use Modi's method yet, because you have to have 5 non-empty cells. But you can use the information that you have before, which is the ones that are empty equal to 0. So remember, the empty ones are 0. So to fix this so that we can actually, do the working out, we can basically just bring in one of those 0 values into our basic variable kind of situation, into our make it a non-empty cell by putting in a 0 in its place. So I'm just going to choose, this one over here so that it matches your notes. That's the only reason why I'm choosing that one over there. If you had more complicated, tables, you would choose it so that when you work out your R's and your K's, it's going to be easier for you. Because remember, when you work out your R's and your K's, you need an overlap, because there will be, one of those situations where you don't have the K value and you don't have the R value. But in this case, no matter where you put that 0, it's going to create that overlap anyway. So this example is not a big deal. There can be situations where, if there is only one specific one that's going to create that overlap, you will want to do it like that. But you will very, very clearly, when you start doing the Modi method, get to a point and go, I can't continue. And then you can go back and be like, well, maybe I should actually use one of the other variables as 0 so that I can get this working out. Okay, so the only thing that you do in this situation, you check the number of non-empty cells. If they do not match the number that you need, you shove in a 0 into one of those slots, or however many slots you need to put in.
Ma'am,
Yes?
does 0 not count as an empty cell though?
So the thing is, if you have it standing there, it's counted as a non-empty cell. If you leave it blank, then it's counted as an empty cell. Because when you're doing your working out, what you're basically doing is you're saying that those are the ones that are actively contributing to your objective function. And those are your basic variables. And again, we don't discuss this with you too much because of the math involved. But you are then saying that that constraint is binding your extreme point. If it's binding your extreme point, it is active, and that one variable, is working for it. So the whole idea here is you need always, and this is the math that we don't teach you, it's a little bit frustrating, but you need to have always like 5 basic variables. Now, a basic variable can equal to 0, and then you have the rest are non-basic. There's actual math that you do behind the scenes where you can neglect the non-basic variables because they're not making an impact, but that there has to always be 5, and it's because of the way that we work with the matrices and things like that. So there is a reason for it, and this table kind of hides the math away from you. So just be careful about that. I understand, I get the frustration because you're like, but all those are 0. But the moment you put it in there, you're saying that that one's active, and then you can use this cost to work out the R's and the K's. That's where the difference is. So you well, that's part of our optimal solution, and the rest don't count. And then you move on from there of processing it. Very long answer to basically say we don't teach you the math behind this. Okay, so just be careful about that.
I
Yes?
just want to ask if you could, okay, could I put the 0 by the 5 or the 21 or the 17? Does it have to
Oh,
be by the,
yes. You can put it anywhere as long as you end up having, you can solve your R's and your K's. In this
Okay.
example, you can put it anywhere. I'm literally just choosing it by the 12 to match the notes available on the website, so you don't get overly confused by it. Right, so again, just bear in mind, you
Sorry,
just
ma'am.
shove in a 0. Yes?
So if we have like 4 values in a table, we basically have to add a 0 in order for us to have 5 values.
Yes, but remember the 5 values comes from how many columns and how many rows you have. So in the previous example, we had to have 6 non-empty cells. So you must always check that. It's always connected to the number of the columns and the number of the rows, which is connected to the number of your decision variables that you have.
Oh, okay, thank you.
Okay, so again, be very careful with that. It is a rule, and it's a rule that's actually connected to the behind the scenes math kind of situation of it, to do with the fact that, and it's to do with the fact that you're going to have a corner point made by the linear independent constraints. And it just so happens that whenever you work out these, you set this up, there will be the number of columns, the n plus the m, minus 1 linear independent constraints. So it's connected to that. It's kind of the math we don't teach you. The table does it all for you, but you do have to have this check into place. So you always count the number of columns, the number of rows, subtract 1. That's how many non-empty cells you need to have. But the fix is just borrowing from those zeros, borrowing one of them and shoving it into the table so you can activate it to go do your working out. So it's basically just moving it from a non-basic variable to a basic variable, even though it is 0, because technically basic variables can be 0. And Matthew, luckily you don't have to do it. It's to do with convex set theory. Okay, and you can put it in anywhere as long as you end up having the R's and the K's working out. It can go anywhere. So you could have put it in there or there or there. Right. So that's how you're going to fix this situation.
Sorry, ma'am. Can I please ask? You said we always say the number of rows minus the number of columns. It's just that now I'm seeing it and
The number of rows plus the number of columns.
oh, plus. Okay, okay. Thank you.
Okay, so the number of rows plus the number of columns, then you subtract 1. And that's actually telling you the number of linear independent constraints which are making up your corner point. Right. And so we put in that 0. We now have the 5 non-empty cells, which means we can continue. And then we get to do pretty much the exact same thing we've done now for a couple of rounds, where we go through the MODI process. So obviously to do MODI, you have to have it so that, the non-empty cells have that specific number and your supply and your demand are equal to each other. And then we start the process all over again. So let's just go to a fresh piece of paper and put that in, and we can start. 90, 20, the 0, the 70, and the 20. And when we start, remember, we work out the R's and K's based on those active ones, the basic variables. So we work out that Cij is equal to Ri plus Kj. And when we work that out, we do it so that we can actually solve to figure out what the differences are of bringing in the other variables into the solution. So we have that Cij minus the Ri plus the Kj kind of situation. So we start with the R's and the K's. So we go through the process again, and it's the non-empty cells for the K's and the empty cells for the differences, because we're switching. When we look at the differences, we look at increasing those ones. So let's go through the process. We always have R1 is equal to 0 in this module. In real life, it's just slightly different. You select based on what makes your math as little as possible. So we have R1 is equal to 0, and we then go 10 minus 0. Remember, we just do that. We have Kj is equal to Cij minus Kj. And we go through the working out. So we work out all our Ks. Then we have 15 minus 0. K2 is equal to 15. We don't do this one because it's empty. Don't do that one because it's empty. We move down, and the fact that that 0 is there, it means it's a basic variable now, which means we do use it. So we can use that 12, and we can use that K to work out that R. So we have, R, the subject of the formula is Cij minus Kj. So that is 12 minus 15, and that's going to give us R2 is equal to minus 3. Then we move on and we solve the rest. So we're going to have, 19 minus 3. That's going to give us 22. Yes, 22. Then we're going to look at 4 minus 3. And that's going to give us 7. So we have the fourth one is 7. We've worked out all our R and Ks. We then work out our differences. So you see, at this moment in time, once at this round, it becomes a lot easier and a little bit repetitive to, practice. So now we work out all our differences.
And where did you get the minus 3?
Okay, so the minus 3 is I took the cost there of the 12 and the K, and that's your cost minus your K value. So RJ is the cost minus K.
Okay. Thank you.
Okay. Right. So once you have all your R's and your K's, and again, it is going to take a little practice, particularly the switch over. So for example, for this one, and I just want to bring this up because it's going to make your life a lot easier when you work out your R's and your K's. Always look for a column where, it's filled in, because then you'll be able to work out, your K before your R kind of situation, because you can use that R and then jump down. So you'll always have to look for the one that has overlapped to solve for your R. If you had selected your 0 elsewhere, you would obviously have to, choose the other one. Right, so let's work out our differences now. So our differences is your Cij minus your Ri minus your Kj. So we have 21 minus 0 minus 22. That gives us minus 1. Then we have 17 minus 0 minus 7. So remember, I'm just going and taking those values from their individual spaces. And that is going to give us 10. And then again, we go to the other the other empty cell. And that will be 5 minus 10 minus 3. And that is going to give us minus 2. Right. So now we have our differences and we utilize our differences. So remember, our differences are telling us if we have to bring in, these in as basic variables, which means usually greater than 0. So if we had to bring in x21 or x13 or x14 into our basic variable set and increase them by 1 unit, it's going to have an impact of, minus 2 times the 1. So it's going to decrease the objective function. X13 would also decrease the objective function. 1 unit x13 is going to decrease it by minus 1. And then you have the 10 situation that will increase it. So obviously we don't want to bring x14 into our solution. We want to look at x13 and x21. And obviously we want to do this as fast as possible. So we go with the one that has the most impact, which is the minus 2. So we choose obviously the most negative. So we're going to bring this one into our basic variables. In other words, we're going to make x21 a value. So it's going to become a non-empty cell. And if we're going to do that, we have to increase it, right? So we have to have that plus sign happening there. And that means we have to go through the whole process of making sure our constraints are going to be met again. So if we increase x21, we are going to have to, keep our demand being met. We're going to have to decrease this one over here. At the moment, we don't know how much we're going to decrease it by and increase that one by. At the moment, we're just focusing on, we increase here, we're going to decrease there. And then we can go through the process of, well, if we decrease, and let's just use another color here. Not red, maroon. If we decrease this one, that impacts our supply constraint, which means we're going to have to, to keep that constraint being met and being on the extreme point, on the boundary of it, we have to have, an increase happening wherever there is non-empty cells, because those are the ones we can play around with. So wherever the non-empty cells are, we can increase that to balance it out again. So to balance our supply constraint out. So we have that. If there were more, and this is where I'm going to now jump back to the supply constraint of factory B and x21, is if you had to look at this, and if you had to increase this one here, you obviously have to increase it and remove from the others to keep this constraint of the 90 being met. So you would have a case of, when you're going through this process of, you can decrease from this one, which you can literally decrease 0 from it. You can decrease from this one, and you can decrease from this one to keep that constraint, being met. Now, when you look at this, remember you have to make sure that all your constraints still remain met. So you need that loop function occurring. So in this case, the only loop function you can have is obviously you have to go, this is a given, you have to have that one. And because this is the only positive one available, you have to go to that one there. And that's pretty much going to tell you exactly, when you go, because you have to now meet this constraint that you have to go down in this case. So that would be your loop. And I understand you're like, but it's going to have 0. I promise you it is going to work out. There's a reason why we did choose this 0 to make this happen. So you can see what happens when it's like this. So you have your loop. And now remember, with your loop, you look at the ones that are negative, because those are the ones you can take from, and you select the smallest one of them. In this case, the smallest one is 0. So what's happening here is you're taking your x22 and you're making it a non-basic variable. But the thing is, x21 is now going to be 0 anyway, but it's going to be the basic variable. It's going to be the non-empty cell. So you can only increase this by 0. I know it doesn't make sense, but you can only increase it by 0 according to your rules. Because you only have, that 0 to play around with, to subtract from. And that means this is still going to stay 90. This is still going to stay 20. But what's going to happen here is that this one here, let me just put a gigantic cross on it. That's going to become an empty cell. So you moved your non-empty cell just across in this situation. And that gives you a new table. So let's write that into a new table. So you have the 90, you have the 20, you have the 70, you have the 20, but now you have the 0 chilling over there. So you haven't made any changes yet, but you have moved, what your basic variables are. And now you get to do the entire process all over again. So this is what Modi does. You have to do the process over and over until you have none of your differences, or you have all your differences greater than 0, or none of them less than 0. So now we have a new table, and we start the process all over again, which kind of sucks. If you had selected this 0 to begin with, your life would be a lot easier. But we did this on purpose so you know what to do in that situation. And technically the lecture is over, but I just want to do like maybe 5 more minutes just to run through it so you can see that you're not going to keep on looping. There is going to be a difference. So you can work out your R's and your K's. And what I'm going to do now, I'm going to just give us the R's and the K's so we can get, the fun parts. So we have R1 is equal to 0, R2 is equal to -5, K1 is equal to 10, K2 is equal to 5, K3 is equal to 24, and the fourth K is 9. And once you have that, you can work out your differences. If we work out our differences, we'll have -3, 8, and 2. So obviously this one is going to enter. And then we go through the entire process again when we have that's going to be positive, that's going to be negative. You can either, add to that or add to that. And we look at the top row, we can either subtract from that or subtract from that. We know that that is for definite. We need another situation where that's going to happen. It happens to be this over here. And we have our loop. So I promise it is going to change. We then have a loop again, and we follow the process of the most negative. So that's 0 now. It has a positive, so it's not going to make an impact on what we're going to bring into our basic variable. The negatives always have the impact because they're the ones you're taking from to maintain your constraints. So we can actually add 70 here, subtract 70 here, subtract 70 here to get 20, and add 70 to this one to get 70. So there is the process where we go about working everything out. It's a bit tedious because you have to go work out your R's, you have to go work out your K's, you have to go work out your differences. You have to check that your differences, if they're all greater than 0, then you're done. If they're not all greater than 0, you choose the most negative of them. And then you find this loop, look at your most negative ones, because those are the ones that are playing the role of everything, and utilizing those to get your new table. This new table would look like, okay, the 90 becomes 20, this, and then so you have 90, let's just write this here, 20, 20, 70, 70, that would be blank, that would be 0, so it's going away, and that would be 20. So that would be what your new table kind of looks like. So we follow this process, but we'll discuss it again on Monday and go through some more steps. And that's it for today. Enjoy the rest of your day. I promise you it's not that hectic once you get used to the algorithm. You have a question?
Yes. Ma'am,
Yes?
you lost me when you started filling in values. Empty.
Which values? The R's and the K's?
Like the 21 minus 0 minus 22 equals -1, and the 17 minus 0 minus 7 equals 10. Just before you started doing the box stuff, the circle or with the arrows, those little blue lines?
Yeah.
Yeah, before when you did it with the first 4 blocks, the W1, W2 for FA and FB.
Okay, so you're talking about like trying to find out which ones are going to be the positive and negative ones?
Yeah.
Okay, so for that, let's just rub this out.
And then also when you did, I don't know if you want to go back on the slides, but when you said 21 minus 0 minus 22, where did you get the 0 from, or did you just...
Yeah.
Yeah.
It's
the 21 minus 0.
It's the R1 value. So when you're looking at your difference, it's your cost minus your row minus your column. So it's the 21 minus the 0 minus the 22. So that would give us a DIJ.
Okay, then what about the FBW1 where you said 5 minus 10 minus -3? I understand the -3. Oh, so did you just put in a different order? So it would have been 5 minus -3 minus 10.
Yeah,
Okay.
you can put K or R first. It's not a big deal.
Okay. And then what are those values?
So the D's are the differences. So when you interpret these D values, they're basically telling you that if you had to bring in, for example, x21 here, if you had to make x21 equal to 1, it's going to have a -2 impact to the objective function solution. So it's going to reduce the objective function solution by that -2, which is why you would want to actually bring in x21, because your idea is to minimize your objective function. So it's the per unit cost reduction that is possible by allocating x21 as a value of 1 unit.
Okay.
But forget the fancy terminology and just see it as its impact on the objective function. So negative means it's going to decrease the objective function. Positive means it will increase the objective function.
Okay. Thank you.
Okay, and then we go back to the loop system. The loop system, was that where you were also getting slightly confused with?
Yeah.
Okay, so that is something that takes a while to get used to. So let's go through that approach. So we have, we selected based on the negative difference because the most negative difference is going to have the largest impact on our objective function. So we're like, well, we want to then bring this one in as a value because every time we bring in a unit of that, it's going to decrease our objective function. So that's where that comes from and where we select it. If that's the case, we have to increase the x13 value, right? Because right now it's telling it 0. So we have to increase it. So that's where the positive is coming from. But we also have to maintain our constraints. So when you look at this process, and I think the column one is the easiest one to see, is if we had to increase this, and this is sitting at 70, we have to actually reduce this one here for it to remain 70. So we have, that one has to be negative. So the column one is the easiest one to see. But you have to then remember and be like, okay, if I, reduce this one here, it impacts this constraint.
Yeah.
So I have to fix it. And this is, it's just piling up kind of a situation. So I either have to increase this one over here, or I have to increase this one over here. So whichever ones are non-empty, because they're already in your basic variables, we already know we have values for them.
Okay.
So you're like, okay, I have to increase one of them. But you also know that if you increase one of them, it affects that one's column. But the easiest way to, make that loop system is to go back to x13 and look at that row. So you're like, let's also fix that row. So we've plus that one there, which means we have to either subtract from this one or this one. And then you try to, you create a loop because you don't want to impact every single one of them. You want as little as possible impacted. So you're like, well, I know I have to do this one. That's an obvious one I have to do. I have to subtract from that one and give to that one. I could either, subtract from that one or that one, but I already know that, I have this like really cool channel occurring over there. So you have that overlap kind of situation. So you have your parts of your loop and then you just connect them. So you're like, well, then I can do it like that. So then you have the interaction, you have it so that all the constraints will be met now when you do this loop system.
I see. And then just lastly, where did you get the -3 and 8 from?
Those are the differences. So it's the differences is your cost minus your row minus your column. So 21 minus 0 minus 24.
Oh, because it changes now, doesn't it?
Yeah, it's going to change for every iteration.
Okay.
Which is the part that sucks because you have to do the math every single time.
Yeah. Okay. Thank you.
Okay, no problem. Okay, so there is a question on the chat where they ask why the Ks change. So the Ks are going to change because your values which are non-empty changes. So if you look at the previous one, if you look at this one over here, where you have your 0 over here, your K working out for this value. When you go ahead and work it out, let's just jump there. We had K is equal to 15 and R1 is equal to 0. But remember, when we work out our R's and the K's, they're dependent on our cost from our non-empty cells. So the very next table that we have, this is no longer a non-empty cell. So the K that we actually got from that one has to change with it, because again, it's based on the ones that are active, so the non-empty cells. So when we go ahead and work out again, you'll notice that K is going to change to do with that. And you'll notice that's the only one that actually really changes, is that K, and then your R kind of situation will change, connected to the fact that this is no longer a non-empty cell, which means our R's and the K values for that column and that row have to change based on the one that is now non-empty, which is the next one over here, which is the one connected. So when we work that out, we have to, work it out based on going through the approach. So in this case, we would have to use that 19 to get our R2 is equal to -5. So we'd actually have to utilize, we get our K, which is 21 minus 0. We get our K value, and then we can get our R value by, utilizing that K value and that 19. So we have, 21, wrong way around, 19 minus 21. Did I do this correctly? Is my math correct? 24. Wow, I can't read my own handwriting. 19 minus 24, and that's going to give us our R2 is equal to -5. So just be very, very careful. Your R's and your K's will change, in particular connected to the rows and columns where it is no longer a non-empty cell. So the rest would usually like chill and stay the same, but the rows and columns connected to the non-empty cell, those rows and columns numbers are going to change, and you're going to have to recalculate them based on the new information you have, because it's always connected to your active decision variables and your basic decision variables. So just be very, very careful about that, and make sure that you're looking at the non-empty cells when calculating your R's and your K's. And I think we'll end here today and continue this on Monday. I will try and upload another example, maybe just on paper instead of on the screen, to just work through some of the exercises. Enjoy the rest of your day. Hopefully I didn't make you too late for your next lecture. K2 is just your 15 minus your 0. Doesn't look like 15, but it is 15 minus 0. Let's just write this a little clearer. So don't forget, it's your Cij is equal to your Ri plus your Kj, which means your Kj is equal to your Cij minus your Ri. Okay, so I'm going to hang around for questions for another 2 minutes, and then I'm going to end the meeting.
Ma'am.
Yes?
I don't know if you could just possibly go back to that last slide again quickly.
The one that I was just on.
Yeah.
The one that. Okay, hold on. I think I stopped sharing my screen. Oh no, it went to the other page.
Maybe you don't have to show it, but I just want to ask, how do you calculate the new K values? I know it's the cost minus something, but it's a small amount, and then is it minus the second row's amount? Or
Okay, so it is usually connected with the one that's active. So for example, if you, let's just do it on this page here. If I had to select, if I want to find K3, I can either use this block over here to do it with, or this block over here. So you would use, like if I want to find K3, if I'm using this block to do it with, I will use the row connected to this block. So then I'll use that R value.
Ma'am, you're not sharing your screen.
It's highlighted in red. No, did you? Let's try this 100 more times. Is it showing again?
There you go.
Okay. I disconnected other monitors. Maybe it just decided that meant it didn't exist anymore. Okay, so let's just have a look here. So it will be connected to whichever block you're utilizing. So whichever cost block you're utilizing, cost value. So if you're using 21, you will use the row connected to that 21 to work out the K. And it's, the K is connected to the column of that cost value. But if you were trying to find, for example, the fourth one here, again, it has to be the one that's non-empty. So you would look at this column, but the only one you could utilize is this block, which means it's that 4 value that you need to use. And that means this row number will be the one that you use. That's where the I's and the J's come in. Remember, J is your columns and your I is your rows. So when you're looking at cost 1, 2, it'll be cost 1, 2 minus row 1 will give you K2.
I see. And then when we worked out the previous R2, we used the 15 minus 12, and then we had, or 12 minus 15, and then we had, 12 minus 15, then we had -3. Why do we say 12 minus 15 and not 15 minus 12?
Okay, and it comes down to the working out of it. So remember, you have your Cij is equal to your Ri plus your Kj. You're now making R the subject of the formula. So
Okay.
it's Cij minus Kj.
Okay. And then if the 0 was in the first column, would we then use 5 minus 10 and not 12 minus 15?
Yes, you'll use whichever one is the active one, not the non-empty cell.
Okay, cool. Thank you very much.
Yeah. That also brings you to, exactly which rows and columns are going to change based on which variable leaves the non-empty cells and becomes empty and which one comes in. Whichever one is leaving the non-empty cells, those rows and column values are going to change for definite in your next iteration. So if you get used to it, you can get a little bit lazier in your calculation of your R's and your K's because you'll know exactly which ones are changing. That's going to come with a little bit of practice.
I see. Thank you very much.
Okay. Any other questions? Okay, so enjoy the rest of your day. And I'll see you on Monday. But just a heads up for those of you that are still in the meeting, usually the test covers up until example 2, but I'm still going to show you how to do the other things and just answer questions related to transport next week.